So in this section, we are going to talk about setting up checkpoints. So let me remind you a little bit about the BWT. So the BWT matrix is formed by sorting on the cyclic rotations of the string. That is why if you search for patterns and the pattern appears in the string, there should exist a row that this pattern appears as prefix. And if the pattern appears at multiple positions in the string, these rows should be consecutive, like this in the picture. So this one allows us to represent the result by using just two indexes, the top index and the bottom index. The next property of using BWT for searching a pattern is that we iteratively build the patterns from the end to the start, like this. So searching a pattern using BWT is an iterative process. In other words, what we do is just updating the indexes. For example, in this case, we start with an empty string so that the indexes can be from 0 to 13. When we start finding A, the index is 1 to 6. When we add one more symbol to A, that is NA, the index is updated from 9 to 11. And when we add the final A, so we are searching for the pattern ANA, so the index is 3 to 5. Okay? So let's look at a little bit more detail. So this is the first column, the last column, which is a BWT, the index, and the last two first, which allow us to quickly allocate the positions of a character in the first column very quickly. So this is at one iteration. So in the next iteration, we are actually moving to this range of indexes. Okay? So the pseudocode for the BWT matching is described as an iterative procedure. But if you believe me and try to code like this, it will take you a very long time to run. And if you analyze the code, most of the time the program will spend its time in this region. So updating index is actually a critical point in this algorithm. It's clear that this way we cannot update the index in a constant time. So I have to describe another definition so that we can come up with a faster approach. Let's define the count of a symbol for an index I and a string text as the number of occurrences of symbol in the first I positions of the string text. For example, the count of the symbol A with index 4 in this string is equal to 0 because there's no symbol A appearing in the first 1, 2, 3, 4 characters. But the count of symbol N in this string is 3. So let's look at the algorithm again. This is the last column, which is the BWT. This is the first column, which is obtained by sorting the last column. This is the indexes. You can see that here we add some information over there. So for each index E and for each symbols in the alphabet, we calculate a number. That is the count of the symbol I. The count of the symbol at the position I in the last column, using the last column. So using this information, we can update the indexes. But can we find it quickly? Well, it's not clear how to find it quickly in constant time. So we have to get another information, which is the first occurrence of the symbol. It's the first position of the symbol in the first column. So this is the first column. The first occurrence of $sign is 0. The first occurrence of A is 1. The first occurrence of B is 7. The first occurrence of M is 8. Right? So using the information about the first occurrence of the symbol and also the count matrix, we can quickly update the indexes. And here you can clearly see that the indexes can be updated in constant time. But you notice that I store too much information here. We don't have enough memory to store that much information. So there should be a way to bypass this problem. This is the checkpoint arrays approach. So instead of storing on the count matrix, now we just store the rows of this matrix, the row I, if it is divisible by a constant C. So what happens if we want to calculate the count of a symbol at the indexes where we did not store? We can construct it by using the information that we stored and looking back at some characters. For example, we look at at position number 10, so we see that A appears. Position number 11, A also appears. So the count of A at index 11 is equal to the count at index 10 plus 2, equal to 5. Similarly, when we want to find the positions of the matching, we need to store the suffix array, right? But even we don't need to store the suffix array completely. We just store it partially and reconstruct if we need to. For example, A and A here, at this position we don't have the suffix array stored. So we can go back to B1, and from B1 we go to A1. So at A1 is the position 1 here, we store in the suffix array is number 5. So we get the information. So in summary, BWT is an approach that you can match the pattern very quickly and efficiently.